Gut, einmal mehr ist es wieder so weit. Einmal mehr freuen wir uns auf spannende, interessante, aktuelle und natürlich frische Talks aus der Cloud Native Community Bern. Wir begrüßen euch alle ganz, ganz herzlich. All die Köpfe winken, so OK und Speakers von unserem Zoom-Call über einen YouTube-Channel. Und ja, leider einmal mehr virtuell. Wir hätten natürlich gerne wieder mal etwas Physisches präsentiert und zusammen anstoßen, physisch zusammen anstoßen und ein Bier zu nehmen, aber keine Angst, wir haben immerhin, weil uns der Austausch wichtig ist und wir denkt haben, wir wollen mal etwas Neues, ein Element bringen als kleine Entschädigung, einen virtuellen Space ganz am Schluss. Also bleibt dran, bleibt bis zum Schluss, dass wir uns noch austauschen können. Gut, ihr habt ein paar Slides zum Intro, ihr kennt dafür unser Format. Und gleich denke ich, ist es wichtig, auf ein paar Punkte einzugehen. Ihr wisst, dass es unserem Herz liegt. Wir haben für Ingenieur, von Ingenieurs, also es ist für euch, aber auch von euch. Meldet euch im Chat mit Fragen, meldet euch auch bei uns in der Community, wenn ihr Inputs habt. Wir werden uns die Hände dreckig machen, heute vielleicht weniger live, aber die Speakers haben das im Vorfeld gemacht, auf jeden Fall. Und wir sind ja aus der Region, für den Raum Bern. Das Intro auf Berndeutsch, Talks in Englisch. Die Region ist ein bisschen grösser geworden. Wir haben Talks aus der Schweiz und aus Zürich. Ich denke, das können wir gut managen als Berner. Unser Setup ganz kurz erklärt, für die es noch nicht kennen. Das OK und Speakers, wir sitzen im Zoom-Call, den ihr hier auf der linken Seite seht. Ihr sitzt im Publikum im YouTube-Channel und euer Channel ist quasi der Chat, wo ihr mit uns chatten könnt. Stellt Fragen im YouTube-Chat für das Kommunizieren, für die Speakers zu fragen, wenn ihr Themen habt. Und eben ganz am Schluss die Live-Session, wo wir zusammen diskutieren können. Die Organisation ist auch bekannt. Wir sind die gleiche Zusammensetzung wie die letzte Mal, also nicht grösser geworden, höchstens vielleicht ein bisschen älter seit dem letzten Meetup. Unsere Twitter-Handle, ihr erreicht uns über diese Kanäle, auch wenn mal kein Meetup ist. Wie gesagt, es ist ein Event, das auch euch gehört, das der Community gehört. Meldet euch, wenn ihr Inputs habt. Wir sind immer sehr, sehr froh, wenn etwas kommt aus der Community. Vorschläge, Ideen oder Themen, die wir auch aufnehmen können für die nächsten Meetups. Auch hier bekannt in eigener Sache. Wir sind ein Verein, Berner IT Rocks. Wir sind nicht kommerziell organisiert und gleich sind wir natürlich froh, wenn wir ein bisschen Unterstützung bekommen. In finanzieller Form, sei das durch ein Sponsoring von einem Meetup oder durch einen Gönnerbeitrag, dürft ihr unseren Verein sehr, sehr gerne unterstützen. Wie das funktioniert, ist beispielsweise über ein Sponsoring-Kit, wo ihr ein Meetup könnt sponsern mit 500 Franken als Exklusivsponsor, wenn wir ein virtuelles Meetup durchführen. Heute geht unser Dank ganz, ganz herzlich an Chaos. Sie haben das Meetup hier gesponsert. Sie haben im letzten Meetup einen Talk gehabt. Und merci vielmals für das Sponsoring von heute. Gut, ihr habt die Agenda wahrscheinlich gesehen, schon online aufgeschaltet. Wir haben zwei ganz heiße Themen heute von Philipp Meier und Matthias Winzeler von Nexoya, die erste halbe Stunde und nachher ab der 5 der Baptiste Blanc von Takes Group. Das ist auch das Zeichen, auf Englisch zu wechseln, so I switch to English. And I will hand over to Philipp and Matthias Winzeler for the first talk. Please, Philipp.
right, so thank you, Matthias, for the warm introduction, and thank you guys for having us. So we welcome you to our talk about a journey from Cloud Foundry to Azure. We want to share with you some stories about our recent migration we did from our beloved platform as a service, Cloud Foundry, to a new cloud provider. This is me, Philipp. I'm a software engineer working as a product owner for Nexoya, and with me is Matthias Winzeler, or simply Winz, who joined us for the migration and supported us there, and now continues to support us with various topics which we have on the table after migration and other things like this. So yeah, all right, what is Nexoya? We built a software as a service solution which helps digital marketeers to manage and optimize their portfolio. In short, Nexoya will tell a digital marketeer how she should distribute the budget for the upcoming week across multiple marketing channels like Google, Facebook, LinkedIn, Instagram, and so forth to get the best performance out of a campaign. How we do it, or how does it look behind the scene? Obviously, with a lot of joyful events and parties, as you can see on the picture on the right-hand side. Typical for a startup, I think, right? We got founded in July 2018, and actually we're a growing team with majority working in tech. Today, we have already more than 30 customers which use it for the production. They are coming from various business sectors, banking, insurance, but also some smaller businesses, things like this. Just to give you a first impression what we're actually building. Here a small screenshot from our interface. As you see, we mainly crunch numbers for marketing and make it look nice, and use some machine learning to do some prediction for the future, how it could potentially look like. So let's leave the marketing stuff behind us and jump to the problem which we faced in April 2020, so almost a year ago. I remember it was a sunny day in the mountains, it was middle of the first lockdown, and during the day we got this announcement from Swisscom, Public Application Cloud, and that it will reach end of service soon. Well, we didn't expect this announcement much, I would say, so we read it through, and we started thinking what it actually will mean for us. I mean, we were happy users of the services around Cloud Foundry and the easiness it brought for us. Further, we leveraged it for the whole cloud, for all our environments, from development to staging. So actually, what is the result out of it? We for sure run more than 200 containers on these platforms, and we used a lot of services. So, and we assume that we were one of the larger customers on this platform. How it looks, or what it looks like back then. So we built many apps and services on it, and this diagram just shows a subset of the things how it looked back then. As you can imagine, we built a front-end application based on React.js, which talks to some backend services through a GraphQL interface. These backend services are mainly in charge to get all the data from various marketing channels on behalf of our customers as a recurring batch jobs, and persist it in the database. So we do this, so we get a lot of data at least once a day or even more frequent from various marketing channels like Google, Facebook, and store it in our system. Further, as you see in the right part, for example, for optimization service, we also have a larger machine learning stack where we are using the well-known frameworks like TensorFlow or PyTorch and things like this. In general, we can say we use Node.js and Python as our primary programming languages, so nothing special. And also from a storage perspective, we use MySQL a lot in combination with Elasticsearch to do some secondary data storage there. And we have RabbitMQ as a message bus in place. That's how the situation, how it looks, how it looked in April 2020. And you also see an S3 compatible interface, which we use for communication between the services. But first, why did we end up with Cloud Foundry in the first place? And what is it actually, right? CF Push is basically a very simple thing, but underneath it was doing many great things for us. It was using BuildPack to run our codes so that we never had to think about patching images when new high severity patches got published or something like this happened. It was all managed by the platform. Further, we didn't have to think about capacity like CPU or how much is left in general underneath. We didn't have to do capacity planning. We could just scale as we go. We simply specified RAM, and there we go. Also, when it comes to networking or routing, it didn't require in-depth knowledge in the domain. Once we set up our Nexoya.io domain, everything was configured, and all the Ingress stuff automatically got covered by Cloud Foundry. And the same with certificates, right? We didn't have to take care for SSL certificates and things like this. Everything was managed by the platform. So this was basically the level of abstraction for our development team we loved and we wanted to keep for sure. We feared we will be stuck with all the migration and managing infrastructure underneath in the future. And now we fear losing focus of delivering value for our product. And obviously this is very important for all companies and also for a startup, right? To deliver value in the product and not doing something in the back which the customer will never face. But yeah, that's how our journey started and what the problem is which we faced. With that, I would also like to hand over to Vince, who will take you further on the journey about discovering the alternatives.
Hey guys, so let me share my screen. Maybe Philipp, you can quickly unshare. Perfect. Now, so I'm gonna pick right off where Philipp left off. That's the term. So yeah, so we were spoiled by Cloud Foundry's abstraction level and the perks it provided to us. So we were there beginning or like mid last year, and we're thinking about, so if there's no Cloud Foundry, no Swisscom Cloud Foundry anymore, where should we go as a startup? And it's an interesting question because a lot of you tech people, DevOps people probably thought about the same thing. Where would I build my startup if I had one? And for us, we started looking for alternatives, and what's important is our main requirements we have. So what's most important for us is the high level of abstraction. So the idea is our developers should just focus on producing values, adding features to the platform, testing their code, stuff like this, and just rolling out, and not fiddle with infrastructure and stuff like this. So the idea would be we should not, as Nexoya, we don't want to hire DevOps engineers. We more want to hire engineers on top that provide business value, so to speak. So what's important is that we don't have to manage infrastructures. We don't want to make capacity management with VMs. We don't have to patch, scale, stuff like this. We want to use a fully managed service when possible. So we don't want to manage our own RabbitMQ or own MySQL. We better put this value also in developing features. And for the compute, what's important is if compute where apps are gonna run, so they're the same. We want a high as possible abstraction, but we don't want to necessarily go to function as a service, since we would have to re-architect a couple of things, and we just wanted to, for now, migrate without changing a lot of architecture. So we went looking, and one important thing is our location should be the data location should be Switzerland, because we have a couple of Swiss customers, which are very sensitive when it comes to these topics. So that was a very restricting requirement, as you might know. So we started looking, and of course, where do you go first? You look at the hyperscalers, the big guns, they have the biggest catalogs. So of course, we went looking there. And the nice thing about them is you always profit from these endless service catalogs, like they have from VMs over storage to higher level things like machine learning stuff. They have everything in their catalog, and that's where you probably want to be, because you can profit a lot of the innovation happening there. And they also usually offer a lot of different compute options. They offer, of course, VMs, they offer functions as a service, and they offer Kubernetes, and they offer platform as a service. Like there's a multitude of different offerings you can mix and match. And also, like, it's such a competitive space that usually the prices go down pretty heavily. So AWS, for example, has pretty good deals. Yeah. And also what's super interesting for startups is they usually have startup programs where you get either credits or you get even support in marketing, stuff like this. So that's what speaks for hyperscalers. So we were looking at the hyperscalers first. And of course, the first biggest one, AWS. And AWS, when it comes to compute, offers a lot of different things. Some of you might know there's a lot of ways to run your containers, either in the ECS container service or in EKS, which is a Kubernetes offering, or you can also have like a Beanstalk, which is similar to like a Cloud Foundry or a Herzog that you might know. And what's interesting, all these hyperscalers, they have a huge managed service. So they all have MySQL, they all have Postgres, so we don't even have to compare them. They basically offer all the same thing to comparable prices. The thing is with AWS, as you might know, they're not in Switzerland. They will be soon, which is exciting news, but not in our time frame. So that was ruled out. There's Google Cloud, which we as devs and techies like as a cloud. They also offer a lot of different compute options where we could run our apps. For example, the App Engine, which is now these days very mature and comparable to Cloud Foundry and Herzog and stuff. They offer a very mature Kubernetes, as it's somehow coming from Google. And they also have a very interesting things that might be interesting for some of you for hobby projects. For example, Cloud Run is very interesting because it's based on Kubernetes Knative, but you just push your Docker container, but you only get billed for the request times, and they have a great free tier. So that's a nice abstraction, a really high abstraction layer that's just a little bit below function as a service. So that was very interesting. And the cool thing is Google is in Switzerland, they're in Zurich. So that would actually be very nice for us. But we had some customers of us that said, nah, Google, we'd rather not. Interesting. So we went looking for Azure, of course, also. They also have a couple of compute options, app service, Kubernetes, and a lot of different stuff. We didn't really understand where it fits, in which niche it fits, but they have a lot of options, and they're in Switzerland. So you can guess it already. We were also looking a bit outside of the big cloud provider world. So we were looking at the remaining Cloud Foundry offerings. There's IBM, SAP, Pivotal Web Services. There's also other cloud providers, the smaller ones you might know, like Herzog, if you could call it small, DigitalOcean, Scaleway, French provider. But the thing is, they're all not in Switzerland, or they cost too much. You can probably guess which one is more expensive on this slide. Well, so we made a decision. To Azure we go. Because of the Swiss locations. They also provide a very attractive offering for startups. And they offer our managed services. And for compute, we had a lot of options. And we tried to go with the highest possible abstraction. And that was supposed to be app service. App service is the platform as a service offering from Microsoft. And the consultants were, the sales were very, yes, let's try app service. What was important is at this point, we didn't want to fiddle with Kubernetes because there's a lot of knowledge involved for Kubernetes. And then, of course, as you said, we didn't want to hire DevOps engineers. So usually with Kubernetes, you need some kind of people that are skilled in this. So we tried to go, we went with app service. So within 2 months, of course, like in the last 5 minutes of the App Cloud's lifetime, we migrated away from Cloud Foundry to Azure, to app services, as we said, and we ended up with this architecture, so to speak. We use Terraform. We used Terraform in projects before, and it proved very well. So with Terraform, we could basically programmatically describe everything we wanted to set up on Azure. And for example, virtual networks, all the app services, the database, everything, the storage accounts, everything can be described in Terraform. And we also had a couple of third-party providers, for example, Cloudflare, which we use for DNS, or Cloud AMQP, which we use for RabbitMQ. We can also specify this. So we have one huge Terraform thing that just deploys whole Nexoya tech stack, which is really nice. On the right side, you can see it a bit what we have. We have a blob store, we have Docker registry, we have the app service plans running the apps, and we have a MySQL server, we have an Elasticsearch, and we have another blob storage. So for the data, another blob storage for the web applications. So I'm aware this is very high level, but that's roughly how it looks. And maybe to come to a closing soon, how was our experience? So how did it feel to move away from our beloved platform as a service and went into the hyperscaler Azure space? So first thing is it works stably, which is nice. We were positively surprised by, for example, by some service offerings. So that's probably one of the pros of going to a hyperscaler. They really invest a lot in their services. And for example, the MySQL offering has a ton of different features, very mature, so many features that we didn't have before, which is really nice. And it works out of the box, and it works until a couple of terabytes. So it's really nice. The support was very good. So whenever we hit issues that we couldn't track down ourselves, we could just shoot the support an email, and usually you get like an answer, a very dedicated engineer that just looks for you, and that just costs like $100 a month. And we probably used it a couple of times. It was, well, these $100 you should spend them if you're on Azure. The docs were good. And the tooling Terraform support is also very nice, yeah, because it's just Azure is everywhere, so the tooling support is also very nice. Some drawbacks, of course, now we had to build hyperscaler knowledge. We had to know how Azure and its VNets and routings and DNS and private links and all this stuff works, which is actually probably not something you would call creating business value for a startup, but that's probably the less of all evil. So. And also we noticed that the quality between different services is really has a lot of bandwidth between the quality, so to speak. So for example, the DBMS services are very good, where in other services you just think, hey, is this even finished, guys? So like, for example, the storage account, it has no S3 API. And if you ask the guys, hey, the whole industry is standardizing on this protocol, why don't you? And they say, you can deploy a menu in front of it, which is a hack at most. So some stuff is really questionable, but mostly it works. You just have to find your way around some rough edges. Unfortunately, we don't have any Elasticsearch and RabbitMQ offering in Switzerland yet. You might know it, it's probably because Elasticsearch is because of licensing stuff. There is Elastic offering Elasticsearch on Azure, but not in Switzerland. And RabbitMQ is not offered on Azure by Azure itself, but you can use Cloud AMQP, which is a third-party provider, and they provide it on Azure, which is really cool. So this is nice, it works. What hurt us the most is probably the app service in hindsight, because first we thought it's nice, it's a platform as a service, you don't have to build Docker images and stuff. So they have something like build packs, what we figured out they don't really work, at least not for our use case. So if you have a more complex app, for example, Python machine learning, the build packs don't work. So you end up building Docker images, and Azure App Service expects you to do some nasty things in your Docker images. For example, adding a SSH daemon so that you can debug it and stuff like that. So we were like, okay, why would you do this? App Service is really just meant for HTTP traffic. So you cannot run a headless app, for example, a worker container, something we were like not expecting. And the thing that hurt us the most was the concept of plan VMs. So in Azure App Service, you have to actually allocate VMs underneath, and then you put your apps on the VMs, and then use your app scale with the number of VMs. So you put there 5 plan VMs. You can put as many apps on it as you want, but they will always run in 5 instances of how many VMs there are. And this makes it very not nice for us to scale, because we have a couple of components that are highly scalable. In the morning, we run like 30 adapters. So in the morning, we have to run 30 VMs, which is very expensive and also not really flexible. And also, they don't really provide isolation. So if you put a lot of the apps on your plan VMs, then they can eat up all their resources. Yeah. What we also saw is downtimes, a couple of downtimes, and it's due to file storage migration or something like that, which is not something we actually should be affected by because we're cloud native stuff. And yeah, in the end, also it needs some plumbing to be a CF-like path. For example, the certificate stuff and logs and downtime-free deployment stuff you have to build on top. So it is actually not a CF. So we talked to Microsoft to get some. We got some free some consultants, which is really nice. And they said, hey guys, if you have these scaling requirements, please take a look at Kubernetes, which is what we're going to do, which was what we already did. So first we were scared a bit about Kubernetes and its complexity and stuff. And we did a small little POC. And I think these days you can easily get a platform as a service with just a couple of tweaks. For example, you can enable auto scaling, auto patching, auto app upgrades on Kubernetes so that it actually just feels like you don't even have to manage hardware underneath. You can also use spot instances, which go with a fraction of a price, so you can save money. And there's a million different tools out there that really makes it easy to use Kubernetes like a platform as a service. We use the Carvel tool suite, which is from ex-CF developers, which really work pleasantly. But of course, this means if we're moving into the Kubernetes space, we're going to have to put some training for our developers. But of course, there's a lot of training out there, which we can just point them to. And everything else in our setup will be standardized so that they don't have to interact with Kubernetes that much. Yeah, cool. And for us, we're going to deploy our CI/CD pipeline is now going to deploy everything, or it will soon be deploying everything parallelly to both stacks, app service, and probably Kubernetes. And then we can migrate live on demand. So yes, that's our journey. We learned a lot. It was a pleasant experience to make our feet wet. What's the expression? I don't remember. But yeah, I think we learned some interesting things. Do you have any questions?
So thanks a lot, Philipp and Vince. We have a few questions in the chat. I can just ask you about the first one. It's from an anonymous user who would like to use, would AWS have been your favorite provider given they'd have been available in Switzerland?
That's a good question. Me personally, I have worked with AWS in the past, and I probably would have preferred it over Azure. But also Google would also have been probably my preferred option, especially with the Cloud Run, which sounds really promising.
Yeah.
But yeah, AWS. From my side, probably AWS. Yeah.
Maybe also can jump in. I see there was another question. Why the people are going to Microsoft and not to Google? Both are interested in your data or something like this. So just to why we didn't went to Google was some customers saw some conflicts in interest, right? So when we do a marketing thing, we building a tool which is optimizing digital marketing campaigns, and one of the leader is Google, and they don't want, or they don't like to see us running our stuff on Google, and that Google could potentially, or in whatever scenario, look into the data, for example. So this is one answer to this as well, why we couldn't go to Google. And for AWS, yes, if it would have been in Switzerland in this time frame, most probably it would be very interesting for us, right? But unfortunately, Swisscom announced that they will shut down the Cloud Foundry by end of November. 2020, and there was no light of AWS in Switzerland back then.
We actually reached out to a couple of AWS consultants to ask, hey, is it actually happening? Because we heard these rumors, but there was nothing fixed yet. So. Okay,
thanks a lot. I think that'll answer the question very well. The next one is from Thies. He asked, did your migration need to be downtime free?
No, it didn't. It was not downtime free, or I mean, it was downtime free, but it was not a requirement. So we are a SaaS, and our user group is not using it in every hour. So we could announce a maintenance window. That was fine. And maybe also interesting, or what we decided for, is the migration approach. So to keep the developers working and everything in development up and running and not losing the focus with the migration, we decided to first migrate the production environment and then go on with integration and development environment, right? Which worked out quite nicely. So Vince and me, we could completely focus on the production thingy. We could train all the migration steps which we had planned. And it was, in the end, it was a downtime of, I think, 1-2 minutes when we had to switch the domains. And yes, that's it.
Mm-hmm. Thanks. There's another question from Thies. Maybe I'll skip that one, Thies, because you already had one. So I'll go to the question of Stefan Benz. If some customers required the data to stay in Switzerland, were they not reluctant with Auth0 as IAM USA?
So we are not in the USA Auth0 instance. There is a European one. I cannot give you. I cannot give you more. At least for us, it works with our customers. It's in our data DPA agreement, and they take it.
And also probably the most, so Auth0 is in some instances just a broker, so there's actually not that many, the sensitive data is in the MySQL database. So that's we have classified our internal data stores a bit, and there's some leverage we can have. What the golden nugget, so to speak, is, and the most important is MySQL and Elasticsearch. But yeah, in Auth0 there's not that much. It's mainly just ephemeral login artifacts, something like this. Yeah.
Mm-hmm. Okay, I think we'll have another one or two questions, and then before we switch. Next one is, how about OpenShift as a Kubernetes-based PaaS solution?
You knew this question will come because there's also a couple of puzzlers in here in Bern, so we should have prepared. We didn't. No, I think OpenShift sounds like a good promise. The thing is a bit, if you look at the ones on the hyperscalers, they're pretty expensive. So there's usually like humans behind, as far as I know. So it's going to cost a human a lot of money. So if you go with a hyperscaler, then what's the, yeah, it's, we could have evaluated it probably, but if you, for example, compare managed Kubernetes offering and an OpenShift offering, is the difference really that high? I don't really know. So, Philipp, maybe you have an interesting point on that one as well?
I'm not sure. Yeah, we didn't evaluate in detail. I'm not sure about the services. If there are Kubernetes not Kubernetes, OpenShift offerings outside, and then if they offer the services which we were looking for as well.
Mm-hmm. Maybe it's just a balance between. So from my gut feeling, we didn't really look at an OpenShift offering at that time. From my gut feeling, the added value compared to a Kubernetes offering is rather small, given the price tag that is higher, or something like this. And I think we actually at some point looked at Apuyo, but the managed services offering, there was, if I remember correctly, there was mainly focused on PostgreSQL. And we didn't also want to migrate the MySQL or like the SQL data store schema-wise.
Okay, so thanks a lot for you two guys. There's some other questions in the chat. Maybe because time runs up, I'll suggest that you will answer the questions directly in the chat. Sure. Or maybe later on, if you stay and if you join our virtual space, that would be a great opportunity as well. So thanks a lot, and I'll hand over now to Baptiste. Thanks.
Hi everyone, and thanks for joining this second talk of our meetup. My name is Baptiste. I'm currently working as 20-minute DevOps engineer and as system engineer for TX Group. And today I would like to share with you how to make 20-minute infrastructure run smoothly. So before we go into the technical details, just a few things to mention to get the right context. Currently, 20minute.ch is the most visited Swiss website. It's also the most read media in Switzerland. We get more than 300K comments per month, more than 5 million interactions, and more than 3 million users. This in mind, when the project to get away from the previous 20minute.ch that was running for the past 15 years and to build a new one, we had in mind to change both the front end, the back end, and also the infrastructure. The goal on the infrastructure side was pretty precise. The first one was to get a 100% uptime. As you might guess, we had a really high load from 6 a.m. to 10 p.m. And we also have some readers during the night. So there was no option here to get downtime even during the nights. And also for the update, the maintenance, and all this kind of stuff, we had to get the 100% uptime. Another difficulty here was that we had to absorb random traffic spikes. So when editors release a hot article like Trump is reelected or the new COVID crisis and things like that, we get really more readers, and it got double, triple, and so on. And we have to be able to absorb this random spike, but this still being able to balance between cost efficiency and stability. With this goals in mind, here is what we have built. So currently, we have 3 environments that are running with the exact same setup, on one for the sandbox, one for the dev, and one for the prod. Both are running on AWS Cloud. We had first the CloudFront, which is our entry point, which is redirecting the request to application load balancer on AWS side. Then we have a Kubernetes cluster, which is AKS, which is managed services by AWS, and the EC2 instances that are running as node. On the app side, especially, we're also using MongoDB Atlas as a SaaS to deploy MongoDB cluster, and we have a VPC pairing between our AWS infrastructure and MongoDB Atlas, which allow us to communicate without being through internet. So before going in details and explaining why we're using each of these parts, let's focus a bit on why we are using AWS on our side. First of all, as you might know, there is a really deep integration between the different services. In our case here, the infrastructure that we have is stable since 1 year, but if in the future we want to get rid of Kubernetes and like run serverless application and things like that, it will be really easy to go in Lambda and just to set up the services and to integrate that to what is currently built. Another good point here is the certificate management, which is pretty easy. Here on AWS side, you just have to create a DNS record to validate your certificate, and it's automatically renewed. It's really something in everyday life that get away from a lot of pains. Third point, as most of the cloud provider, the ingress inside of the AWS account is free, which means that the traffic between the different services, we don't pay for that, since we still have to get in mind the balance between cost and efficiency. They have a really good SLA, and they have proved that during the last years. In our case, for the stability and all this kind of stuff, this was a really interesting point. Matthias also talked about that previously, but the support here on AWS is also really great. The enterprise support allows you to get direct chat with engineer, and it's not only when you have issue, they can also give you more advice when you make some optimization, when you have some question, when you want to make cost optimization and so on. And we use that a lot. It's pretty efficient and really good point. Last point, which is probably the most important one, we already had internal skills and experience on AWS side. So for such an environment that have to be stable, this was really something that pushed us to AWS. So now let's go to the technical parts. Let's go one by one. First of all, the WAF. So as you might guess, we use that to block the malicious requests. In our case, 20 minutes have mostly Switzerland reader, which means that more than 94% of our traffic come from Switzerland, which allow us to apply rate limiting per country to get rid of a lot of attacks, and we have some. The WAF project was chosen after we have set up all the rest of the infrastructure. Here, AWS WAF is deeply integrated with the CloudFront and the ELB, which allow us to make a lot of customization easily. We had also had a look on Cloudflare and Zenedge recently, but for now, due to what we need and how we use that, AWS WAF is perfectly fine. A second point, CloudFront. So as you might guess, in our case, we need a big CDN with a lot of caching and a lot of options. In our case, we are using that. We deploy one CloudFront when we need specific caching. So for example, we have a specific CloudFront for the front end, a specific CloudFront for the API, and we adjust the caching depending on the needs. Good point here to mention, there is 2 edge cache in Switzerland, one in Zurich and one in Geneva, where we have most of our reader. The configuration of the CloudFront could be easily automated, also with Terraform. And not negligible one, price are flexible depending on the volume. So in our case, since we are having high load, we can make some discount with AWS. Third point of this part, the application load balancer. So his goal, as you might guess, is just to split the load between the different nodes of the Kubernetes cluster. In our case, we went for an application load balancer and not network load balancer because we wanted to use the layer 7 capabilities to check if there was some header presence before routing the traffic. We have some security there that also only check if the requests come from the CloudFront, which means that every external requests are automatically dropped. An interesting point regarding that, let's imagine that CloudFront is down for some reason. We can just easily reconfigure the ALB and reroute the traffic directly to it and get rid of CloudFront. So for 100% availability time, this is still a plus. True, it will increase the infrastructure cost for that, but to avoid downtime, it could be done. So we just saw this part here, and now let's go a bit closer to the Kubernetes cluster and how it runs and all this kind of stuff. So in the team, something to mention is that we didn't have a really deep knowledge on Kubernetes. We all know how it works and this kind of stuff, but we were not experts. And we would like to avoid having a full management of the Kubernetes cluster. AWS is offering managed services here, which is called EKS. On their side, they have the master node that is managed. They already made the configuration of the cluster. They guarantee high availability and high observability, which was fine for us. That's why we chose this project. Something else to mention regarding EKS, the cluster is dedicated to the app, which means that dev have his own cluster, prod have his own cluster, and nothing else than 20-minute application is running on that. Linked to this package, the EKS package, we are also using auto-scaling group and EC2 instances. So the EC2 instances are used here as nodes. Good thing with the EC2 instances is that you can really easily change them. So if you saw at some point that your application are more CPU-oriented or memory-oriented, it's just pretty easy to change the kind of instances and adapt your load. The auto-scaling group is making the adjustment regarding the load by scaling up or down EC2 instances is pretty quick. And once again, AWS guarantee here high availability and high observability, which is really nice. On our side, we are making kind of chaos engineering. We set rules for the EC2 instances to not being able to live more than 7 days, which means that after this time, they're automatically killed. And like the loads that were on that is automatically scaled somewhere else by the EKS cluster. Last part, which is more application oriented, MongoDB Atlas. So one of the requirements was to have a scalable NoSQL database. 1.5 years ago, MongoDB Atlas have just been released and make some proof. And so we evaluate this product and choose that. Once again, it's cloud services, so high availability, high performance, and all this kind of stuff. And in our case, on the infra side, we are just managing the organization, which means that the application and the cluster application are managed from the application side. And since we are using micro app, it's pretty easy to deploy. So that's it for the infrastructure part. And let's go a bit deeper on how the traffic is routing. So as you might have guessed, CloudFront is our first entry point. He's doing a lot of caching stuff, which are saving us a lot of loads. And he's also doing this self-termination. If there is no caching to do, then CloudFront is directly sending the request through the ALB over SSL, and then ALB is doing his magic. On our side, we are using traffic as reverse proxy and ingress controller. So we have deployed 3 different traffic pods. These pods have different deployment depending of the availability zone. So on each region of AWS, you have 3 availability zones in case something goes wrong. And in our case, traffic is deployed on each of these 3 availability zones. So if one goes down, the traffic is still routed. That's why there is only 3 traffic here. And once the request get traffic, it's rerouted to the right application. And it's just easy like that. Next part, which was also an important part of the project, was to see how we could deploy that easily and fastly. One of the goals was also to empower the developers teams and like to give them as much autonomy as they could, which means that when we have some feature branch, some dev tests to do, they will be fully autonomous. So this workflow that we have here is the same for the infrastructure, but also for the application deployment. We have our different applications stored in GitHub. Depending of the tags, of the name of the branch, and so on, it's automatically triggered to Circle CI, who is having different workflow depending of the application. Then Circle CI is using Terraform to deploy on each of the environments that is needed. So for the infrastructure, especially AWS, but for the application part, more with M deployment and MongoDB Atlas cluster. Why Terraform? From the infra side, as you might have known, it allows you to describe all the components that you need. And in our case, it means that we can have a versioning of the infrastructure, which is pretty nice when you want to move pretty fast. Another good thing here, when you deploy objects with Terraform, they are stored in their state, which means that on the infra side, if you have deployed an AKS cluster, a CloudFront, or even MongoDB Atlas organization, it's referred on the state, which means that you can do cross-state reference between infrastructure and application, and all of that is done dynamically. Here, for example, if you have a first application that needs to deploy a bucket, it could directly reference to the infra to get the knowledge of the AWS account. If you have to deploy an Helm application with Node.js, it references the infra to get the correct AKS cluster. And if you have to deploy a micro app on Kubernetes side, it references the infra state to know on which organization to deploy. And all of that is done automatically and dynamically, which means that when you have a change on the infra side and you redeploy your application, it's automatically triggered. Other good point regarding Terraform is cloud agnostic. And as you have seen during the previous talk, we are also using that for Azure. In our case, it means also that with one single code, we can deploy on AWS, we can deploy on the Kubernetes cluster, and we can deploy on MongoDB Atlas, which is really, really nice. Another good thing regarding Terraform, especially on the infra side, because we are using that a lot, it allows you to get the organization that you want with your file, which means that in our case, we have divided the infra code in different by component. So we have a CloudFront.tf, an AAB.tf, and so on, which means that when you make some change and when you make some update, it's really easy to see where it has been and you get the right versioning on that. Other good point, it's free to use. So for the cost, it's always nice. It's open source. So when you have some issue there, it's really easy to open a pull request on their side and to get some quick fix. And it's an unfinished version. They are moving really fast and they are releasing new feature, new component on the AWS side and all this kind of stuff, which is really, really nice. The other component for the deployment, so GitHub, pretty common, pretty easy. In our case, we are having like one repo per applications, which allows us to get proper view on what is deployed when and so on. And the good thing here is that there is a really easy integration with our CI tool, which is CircleCI. Why CircleCI? In our case, we really wanted to split the permission between like dev application, front-end application, and so on, which means that on AWS, we have different AEM users. To get like more visibility on what is used where, you can use CircleCI context. So the context are like folders on which you store your secrets, but it's shared on an organization level. And then you can say, okay, this workflow is the front-end workflow. So I want to use that with the front-end context and all this kind of stuff, which allow you a lot of visibility and you don't make any more errors and you don't end up with like 500 secrets stored at the same time. And then you have to precise if it's dev, if it's prod, and all of this kind of stuff. Another interesting thing with CircleCI, you can use orbs. So orbs are like functions. So in our case, since we are deploying Terraform both on application side, backend and infrastructure side, we create an orb with Terraform on which we have the same code and that we use everywhere. So we avoid having duplicated code here to maintain. So that looks nice, that looks fancy, but there are some pain points. First of all, the human errors are still there, even if you have a lot of automation, even if we're versioning and all of this kind of stuff. As human, we always make errors that are sometimes pretty painful to correct since we are having the automated deployment. Terraform is moving fast and sometimes too fast for us. You have to make a lot of updates. We are releasing a lot of major updates. So the good point here is that you get no feature, you get new resource on the AWS side for us, but it asks for a lot of operational tasks. We have different technology to maintain. So Kubernetes, even if it's managed, you still have to make the updates. Helm, traffic, Terraform, Terraform provider, Terraform modules, and all of that costs you a lot of time. Sometimes you also have cross dependencies with Terraform, which requires to get the update in a specific order. The cost management, as in every cloud environment, is pretty difficult to tackle, especially in our case, when we get some attacks, the logs drop drastically and we have to be really careful about that. As I mentioned at the beginning, sometimes we had like really high spike on traffic due to notification to the reader, and the auto-scaling reaction time is sometimes a bit too long. So EC2 instances are scaled up in less than 1 minute, but sometimes it's not enough. So this is still a pain point on which we have to work on. Infrastructure as code, as you know, it needs a lot of time to be that precisely, it needs a lot of rigor, and it needs a specific mindset. Otherwise, you end up with just a huge code, which is a nightmare to maintain. And last point regarding the cleanup, CircleCI cannot hook on branch deletion, which means in our case, since we are deploying all the feature branch on the dev cluster, we can end up with a lot of trash here. So we found a solution with GitHub Actions, but this is still a pain point. What's next? Especially on the infra side, we would like to get a real CI/CD pipeline with some testing and automated deployment. For now, the checks are done manually, which is nice due to the complexity to the infrastructure, but it's not as state-of-the-art as it should be. Cost optimization, of course, we all work in the cloud, so we know what it is. Regarding the WAF, there is still some tunings to do. Currently, it's protecting us well, but you know it's moving really fast there also. We would like also to improve a bit on the monitoring and on the alerting. We have a system of tickets that is used with PagerDuty, and currently it's implemented with Grafana and Prometheus. But still here, it's pretty new, so you have to make a lot of adjustments to be sure that you're not wake up during the night because something which is not important broke. And last part, as I mentioned before, we are managing a lot of technologies, and this is taking us a lot of time in ops, and we want to get rid of as much of that as possible. So that was pretty fast. Thanks for listening to me, and if you have any questions, just send it to the chat.
Okay, thanks a lot. But this is also very interesting. There's a question from T-Threads. What do you use for monitoring and alerting your team in case of incidents?
So currently we are running with Grafana and Prometheus. We have a separate team that have set that up. It's working nice. And for the alerting, we are using PagerDuty. We are also currently evaluating Neuralix to see if it could fit better our needs, but the costs here are drastically higher. But yeah, currently Grafana and Prometheus. And the good news here is that there is a lot of tools integrated also with AWS, so we get a lot of visibility on a lot of services here.
And then we have a question from Johan directly in the Zoom call. What about GitHub Actions instead of CircleCI?
So when we start the project, GitHub Action was not as mature as it is for now. And like some steps that were pretty critical for us, like the approval steps, were missing. Currently, that's not the case anymore. And we start to think about moving some loads there, especially that we are having a GitHub Enterprise account there. So we could have some discounts. But at the time, that was not the case. And CircleCI with the context thingy and the orb was a good solution. But GitHub Action not today could also do the job. Yeah, exactly.
Okay, thanks a lot. I think the questions are mixing up a little bit in the chat. I think the OpenShift question and Terraform questions are not for you, Baptiste, is that correct? Yeah, let me check. Are you considering a multi-cloud at one point, or is it AWS all set?
So we start with Kubernetes to being able to move away from AWS if we need that. But currently it's working pretty fine, and we will probably go deeper on AWS side instead of getting more of a cloud provider. Easiest reason is that it's easier to manage, and like, as you know, they are providing a lot of services. So for now, AWS is set up, and we will probably not move, but we never know.
Thanks. And I think the last question is also for you. So why is it so much infra needed? Is it not a big part of it, just static hostable side?
Not really. A lot of content are dynamically generated, and the infra is not so big. Like, it looks big, but in fact, we are not running so much containers, and we are not running so much EC2 instances. The aim here, and why it looks so big, is that we really want to get the uptime availability. But another point to mention maybe is that the product is moving really fast. And to get the developers a lot of power to move fast, we also had to set up all this infrastructure and this environment with the replication and all of this kind of stuff.
Okay, and Thomas just said that I've missed the question about Terraform. So do you plan to use Terraform for deploying to different hyperscalers?
That was one of the goals at the beginning, which also joined the previous question regarding Kubernetes cluster. For now, we use that for MongoDB Atlas and AWS. If at some point we need also to, for example, to put the WAF on Cloudflare or to move the Kubernetes cluster on GCP, we just have to adapt our provider, adapt our resource, and then everything should be set up at the same way. So that's one of the big strength of Terraform, and for now we don't have the use case, but if later we need to move, of course, yes, we will still use Terraform.
Great, thanks, Baptiste. There's no more questions in the chat, so thanks a lot for your presentation as well. I also hope that you are in the virtual meeting after the meetup. Maybe there's some other questions there. And so I'll switch back. We are just in time. I'll switch back shortly to our presentations. Switch to Swiss German again. Right, let's have a look at our last slides. Okay, ich mache für den Schluss wieder weiter in Berndeutsch, ganz kurz, dass wir wieder ein bisschen zurück in die Region kommen. Wir hätten noch ein nächstes Meetup, das wir gerne announcen. Und zwar werden wir Ende April, am 29. das nächste Meetup durchführen. Das wird ein bisschen ein anderes Setup haben. Und zwar wird es ein Warm-up-Meetup sein für unseren Cloud Native Day, den wir im September haben. Wir werden, wie letztes Jahr schon angekündigt, im September unseren Cloud Native Day noch immer planen, physisch durchführen. Und im April machen wir das Warm-up-Meeting, organisiert von den 3 grossen bekannten Schweizer Cloud Native Meetups aus Zürich, Westschweiz und Bern, die das Meetup organisieren. Also es wird sicher sehr, sehr spannend. Ein bisschen grösseres Format. Schaut rein. Ich würde sagen, save the date. Und freue mich jetzt schon auf die Talks am 29. Das noch in eigener Sache. Und dann wären wir am Ende von unserem Meetup hier. Switchen nochmal zurück auf die View von allen Speakers. Ich hoffe, ihr seht nochmal Bilder. Bitte Kamera an.